Hey Valley Middle, welcome back to another G67 math video. Tonight we're going to be comparing and ordering rational numbers. Before we do that, let's start off with the trivia question. You've been looking at American flags your entire life, but can you describe what the array of 50 stars looks like? I learned a lot. I'll show you what I learned at the end of the lesson. All right, I can compare positive, negative fractions, integers, and decimals with inequality symbols on a number line. Is our official target for tonight? Let's do this thing. All right, which symbol makes this inequality statement true? So we've got negative 0.5305 and negative 7/16. Well, in order to do that, to compare those, you really have to put them into decimals. I'm pretty sure this one's less. This is less than 0.5 because it would be 8/16 would be 1/2. So, but I'm still going to transfer that into a decimal. So if I switch them into decimals, I'll see that I have negative 0.5305 and negative 0.4375. Well, then I have to think about these are negative numbers, and so the rules are a little bit differently. So my next step is after I put them in, make them into decimals, I put them on a number line. So if I put them on a number line here, and it's nothing fancy here, I just made this number line. I got 0, and I got negative 0.5 or negative 1/2, and I got a positive half, and I've got negative 1 over here. Well, negative 0.4375 is going to come right here before negative 0.5, right? It's a little bit less than negative 0.5. Think of this as negative 50 cents, and this is negative 43 cents, so it's going to come on this side. This one, on the other hand, is like a negative 53 cents. That's going to come on this side of the negative 0.5. It's more negative. Well, the rule is that the closer you are to 0, the bigger the number is. So the farther you are to the right, that always will tell you what the larger number is. So this is actually larger. Negative 0.43 is greater than negative 0.5305. So the way you would read this inequality is negative 0.5305 is less than negative 0.4375. Are you with me? It gets tricky. Let's take a look at some simpler examples first. I'm going to move my slides around tonight. I'm going off board. Let's first of all talk about a negative number. Just to review, a negative number is any number on the left side of 0, over here. We call it the dark side. The positive number is any number over here on the right to 0. The bigger you go, the farther you go this way, the larger the number. The farther you go this way, the smaller the number. So if you take a look at this problem right here, and I'll just put it here, we've got 4, and we're comparing it to negative 5.5. Well, let's put 4 on. That's an easy one to place on the number line. 4, and let's see, I got to clone that baby, or I'll copy it quick, paste her in. Let's put this guy in here, negative 5.5. Well, let's think about that. Here's negative 5. So negative 5.5 is going to be a little bit further, right at the end of our line there. Okay, well, which one is greater? Well, this one is furthest to the right. It's the farther you go to the right, the larger the number. So 4 is greater than negative 5.5. I didn't even need to convert that to a decimal, but I think it's a good idea when things get hairy or close and you need to make it into a decimal to convert it. Let's take a look at another problem here. We've got a whole range of targets that fall into here. I can compare positive and negative decimals, positive and negative fractions, positive and negative integers. I can compare and put all those things on a number line to compare them. So I'm combining all of these targets together in one video here tonight. That's why it's 2.2 AB. So the whole series of targets boils down to these things here, comparing and ordering. So here now we have negative 4, we have negative 1/4. Okay, well, let's take and go ahead and let's say you don't really know that 1/4 is 0.25. So let's just go ahead and put this one in as a decimal. So now we've got something to compare. We've got them both in decimal form. So negative 4 would be here. And we have to think about this. Negative 0.25. Well, this is 0 and this is 1. So this would be a negative half, right? So negative 0.25 is going to be right here. Well, which one is greater? This is greater. It's less negative. This one's more negative, so it's less. Wouldn't you rather owe somebody 25 cents than $4? Again, think of negative numbers as debt. Speaking of debt, let's take a look at this problem here. Here's a bungalow, kind of a story and a half house here, and let's say that this house costs $150,000. So your mortgage is the money you borrow from the bank or a lender to buy a house. So if you didn't have any money and you bought this house, you would owe somebody $150,000 you would owe the bank. If you want to get this two-story, let's say that it's $300,000. It's twice as much. Thus, the mortgage would be negative $300,000. Again, think of money that you owe as a negative number. Well, here's zero. Here's the bungalow at negative $150,000. Here's the two-story at negative $300,000. Which one is greater? Well, the smaller the negative number, the less negative it is, the greater it is. This one is closer to zero. This one is farther away. It's more negative. Just remember, when you're on the number line here, I'm going to move these guys just a little bit so they line up with zero. Right smack dab on zero. The farther you go to the right, the larger you get. The farther you go to the left, the smaller the value gets. Okay? All right, I did this one here. Let's jump down and try a couple problems here. Now we got these multi-step inequalities. So which symbol makes this inequality statement true? We got negative 4/5, 0.001, which is positive, and negative 1 1/4. Well, this one here, I'm thinking right now, if this is positive, this has got to be the biggest, right? But let's go through the steps and let's make them all into decimals. So negative 4/5, 4 divided by 5 would give me negative 0.8. And then this one here, 1 divided by 4, we just did, it's 0.25, so this is negative 1.25. So plot them on a number line. It doesn't have to be anything fancy. Here's a number line right down here. I'll just kind of scroll down. So here is this one here, negative 1.25. It's like $1.25 that you owe somebody. It's a negative number. It's right here. This is negative 0.8. We could think of it as negative 0.80 if you want to think about money. This is 0.80. It's like owing somebody negative 80 cents, or you owe somebody negative, sorry, you don't owe them a negative 80 cents. You owe them 80 cents, so it's a negative number. But this guy here, he's on the other side of the zero. Yes, it's super close to it. It's only 1/1000th, but it's still positive. It's the largest value. The beauty of the number line is it shows you that the farther you are to the left, the smaller the number is. The farther you are to the right, the bigger they go. So these placed on a number line are already in order from least to greatest. So now we just have to pop in the inequality symbols. Move this guy over. So this one is the largest. So obviously this one here, negative 0.80 or negative 0.8 is less than 0.001. And again, this one here is greater than that. So 0.001, this positive, is greater than this negative number. Oftentimes you have to go in and put them back in the original form, so I'll just do that real quick. But that's it. That's how simple it can be. Again, the number lines don't have to be fancy. Let's take a look at another one here. All right, which symbols make this inequality statement true? All right, we have 2, negative 2 7/9, and negative 10.875. All right, think about this. I mean, again, this is a positive number, so this is going to have to be the greatest, right? But let's go through the steps. Make them all into decimals. Well, if you make this into a decimal, this is 7/9 is 0.7 repeating, so this is negative 2.7. And this one is already a decimal. So now we can compare it easily. Place those babies on a number line. Well, here's the 2 way over here on the other side of 0. This is the positive number. Here's the negative 2.7. And this is the negative 10.875. It's really clear to see on this one. This one's the most negative. This is the smallest number. This one here is the farthest to the right. Remember, the farther you go to the right, the larger the number. The farther you go to the left, the smaller the number. So let's put in these signs. This one here, 2 is going to be greater than negative 2.7. But negative 2.7, repeating, is greater than negative 10.875. And again, you could just pop in up here too, back into the original form. If they ask for it back in the original form, you can make that back into a fraction. Make things into a decimal so you compare them. You can compare them easily and put them on a number line. Now, if they're real simple, if they're just whole numbers or simple fractions, you don't always have to make them into decimals. But when they get tricky, that's what I do. All right, here we go. Let's try this one. I want you to go ahead and pause the video and try this one on your own. Which symbols make this inequality statement true? Go ahead. All right, sorry, just messing around. All right, make them all into decimals. Here we did it. They're all negative numbers. Okay, and I already put the signs in. Go down here. Look, I plotted them. Look at this is negative 0.675. This is like 67 cents in the hole. I mean, that's not much money compared to $4.70 that you owe somebody, or $50 and $50.50, negative 50.5. So clearly you can see that this is the largest, and this is greater than negative 4.7, which is greater than negative 50.5. Again, think about it. This is the smallest. It's the most negative. This is the greatest. It's the least negative. It's the closest to, go ahead and say it. I know you know it. It's the closest to 0. All right, let's try another one. Go ahead and pause the video. This time I'm going to have you order them from least to greatest. So you're not going to be using the inequality symbols, but just order them. Just draw a quick number line. Go. All right, let's see how you did. Well, you have negative 1.2. You got one decimal here. This is, or one fraction here, 4/16. I made into a decimal, negative 1.25. Negative 1 1/3. I made that into negative 1.3 repeating, just so I can compare them a little bit easier and place them on the number line a little bit easier. So here we go. Well, the most negative is negative 1.3. Here's negative 1.25, negative 1.2, negative 1.15. Again, when you get into these numbers, think about money. $1.15 you owe. $1.20 you owe. Yeah, feel free to put a 0 on. $1.25 you owe. $1.33 that you owe, or $1.33.3. It goes on, I mean, because it's repeating, but you get the idea. This one's the farthest from 0, so it's the smallest. Number lines are great. I don't think you have to be so precise with them. I think just get some values down there and plot them. And even if your intervals are just a little bit off, you're still going to get the idea of what's the least and what's the greatest based upon which ones are closest to 0, which ones are farthest away from 0. All right, get to the show. Go ahead and work on these. Those in order from least to greatest. Put the second ones on a number line. All right, your trivia question of the day. The 50 stars, what does the array look like? Well, take a look at it. You've got rows of 6 and rows of 5. So a row of 6 and a row of 5, a row of 6 and a row of 5. So there are 5 rows of 6 stars of 30, and there are 4 rows of 5 stars, which give you 20, and you could add those together and get your 50 stars. Now, that's pretty simple, but so I started thinking, like, what about some of the other oddball flags? So I found this cool website, and look at some of these. Like, look at the 45 star flag. A little goofy. Look how the line. They look at the array, and I'm not going to count them out. You can check it out yourself. But how about the 43? Where's that one? 43 star. That's kind of goofy. Look at how it's kind of empty over here. Never really thought about it before, have you? All right. Thanks for listening. Check out the arrays on different flags. It's kind of fun. All right. I'll leave you with the original 13-star flag. Have a good evening. Bye.